Hello everybody, this will be the last video for notes for assignment 10 in ABS, aka graphing lines. Alright, the first thing we should do here is make sure the equation is solved for y, and currently it is not. So this is why I went over the solving for y examples in the last video. We need to make sure the term with y in it is on one side of the equation and the terms without y on the other. So this will give me the new equation, 3y equals 2x minus 12. We're almost done solving for y. We have to divide by 3. And so this will give a new equation of y equals 2/3 x minus 4. That being said, we know that this is the y coordinate for the y-intercept. So negative 4 will go into a coordinate pair where x is equal to 0. And the slope here is 2/3. What's nice to note about that is that it is positive, which means the line, as we move left to right, should be increasing or going up. So we begin with the y-intercept. Remember, this is where you begin, B. And when we begin, that's negative 4. We see the y-intercept is 0, negative 4. So the y-intercept is always going to be on the y-axis, which is good to know. And we just follow the slope from there. So I will go up 2 and right 3 because rise overrun. Up to right 3, up to right 3. And again, if you want to go exactly backward, you go the exact opposite direction. So instead of up to right 3, go down to left 3. There will be a point there. Down to left 3. And we want you to graph, I would like you to graph both directions so you can tell that that line, all those points do end up on the same line. And yeah, they do. All right, so then you can draw your line through there, put some arrows on it, and then you can label it. What is it? 3y plus 12 equals 2x. All right, next example. Here we have a new page. You can see example 15 and 16. Pause the video, try these for yourself. Again, solve for y, find your slope and y-intercept, plot your y-intercept first, use the slope to find the rest of the line. So here I am with mostly answers. For example 15, solve for y, you would have to subtract the 4x from both sides. So it'd be 3y equals negative 4x plus 6, and then divide everything by 3 from this y here. You get negative 4/3 for the slope. 2 is the y coordinate for the y-intercept. Plot the y-intercept, follow the slope. Down 4, right 3. Down 4, right 3. This is a negative line. It is decreasing. Looks good. So you do a lot of those same steps for example 16, but what I want to point out here is that the slope is a whole number. The slope, when we're trying to graph, makes much more sense if it is a fraction. You can always put a whole number over 1. So from here, I already have the y-intercept plotted at, 0, negative 1. There it is right there. From there, we will go up 3 and right 1. Put a point there. Up 3, right 1. Up 3, right 1. Down 3, left 1. Down 3, left 1. And I'm out of space. I'm going to freehand this one. There it is. And again, you can label it if you want to. You can put the equation along the line or something like that. All right, 17, 18, fast. 17 is a y equals. This is a horizontal line. All horizontal lines have the equation y equals some number. So in this case, again, how I explained it before, you find the y-axis, you find the number 2 on the y-axis. Boom. And then it's just a horizontal line from there. So this one, it is just way easier to graph first and answer these questions later. The y-intercept is 0, 2. That's where the graph crosses the y-axis. The slope here, though, from video 1, I believe it was, the slope is 0. Horizontal lines have 0 slope. The trick with example 18 is y equals 2x, and there's normally a constant being added or subtracted back there, but if there isn't, it's 0. This is already in slope-intercept form. My slope is 2, which again you can write as a fraction, 2 over 1, and the y-intercept has a y-coordinate of 0. Making this line go right through the origin, you go up to right 1, up to right 1, up to right 1, so on, and you go exactly the opposite, and all of the lines will, or all of the points will fall on the line. Pretend it's perfect, and you can label it if you want to. Last page, let's get through this. Finding equations given a graph. Let me see if I can do this. Remember, last few slides, the most important thing about a line would be a slope and some point on that line. From there, we can make the equation of a line. But that point, we can be more specific with that. I'm choosing my point to be the y-intercept. Why would I ever want the y-intercept to be the point I pick? Well, we know that this point 0, 2, that the y-coordinate of the y-intercept is part of the equation. Aha, okay, so I think that one goes to the end. So plus, let's see, it's a positive 2, we should make it plus. Oh, I know there has to be a y equals. Okay, so y equals. We have the y-intercept, we need the slope. So if I find a second point, I can find the rise over the run, and that becomes my slope, which is multiplied to x. And just like that, you are done with this, done with that question. Try 20. I know you've only seen one example, but try 20. I'll be back in 5 seconds with the solution. And here's the big reveal. The equation here is y equals negative 4x plus 5, because when I found the y-intercept, or where the line is crossing the y-axis, the y-coordinate of that point is 5. And from this point, I found another point that I could count to right here. And the slope, I ended up having to go down 4 and right 1, so negative 4 over 1, but I made it a little bit simpler than that in the equation. You don't have to put the number over 1, just write the rise at that point. Moving to the final topic for this video and for A10 notes. We have the point slope form. And so to be successful in writing the equation for the point slope form, I hope this is obvious, you're going to need a point and you're going to need a slope. So it's a little bit different because this equation right here allows us to have any point on the line and not specifically the y-intercept. So without further ado, you can see that we are given the point, so I'm going to call it point number 1, x and y. We have the slope here of negative 3 over 2, So if I just follow this equation, I can write y minus y sub 1 is 3. And yes, you want to put the values in parentheses and take the extra step. You'll see why in a second. Equals m, that's where I am in the equation up there, negative 3 over 2 x minus x1. So there it is. That is the equation, but you can see that we have a little bit of simplification that can happen here, and that's mostly because of these sets of parentheses. So we can just say y minus 3 equals negative 3 over 2 x plus 4. And that is the slope-intercept form of a line. Pretty straightforward. So let's see. 22, we've got y minus, the y value here is negative 1, equals, the slope is 3/4, x minus x1, which would be 8. So again, we just have to worry about the signs here because we are subtracting these sets of parentheses, we're subtracting them. That will give you the new equation, y plus 1 equals 3/4 x minus 8. There it is. Now these last two, remember for the point slope form, you have to have a point and you have to have a slope. But these last two examples only give you points. Well, now we have to back up. When you have 2 points, you can find the slope. So again, we can call these 1, x sub 1, y sub 1, point 2, x sub 2, y sub 2, and we get to finding the slope. So here it comes back, y2 minus y1 in the numerator, x2 minus x1 in the denominator. And in the numerator, when you combine those, what's that, negative 7 minus negative 1, you're adding the 1, that becomes a negative 6. In the denominator, you get negative 15. So your slope here is 2/5. Now, the cool thing about point slope, now that you have the slope, is you can pick either point, point 1 or point 2. You might be inclined to pick point 1 because that is what is given in the formula here. But either one works. So the equation would be, if I use point 1, y plus 1 equals 2/5 x minus 5. The last example, I'm going to give you a chance to try. I'll come back in 5 seconds with the answer. Here's the solution. You can take y2, y sub 2 is negative 2, minus y sub 1 is 13, x sub 2 is 4, minus x sub 1 is negative 1. Add these together to get 5. Perform the subtraction, get negative 15. Divide it to negative 3. That is the slope. And I used the first point again. When I substitute a negative 1 in here, the negative that is already there makes it positive 1, plus 1. And the 13 will go here with a minus 13. All right, I've taken way too long in this video. I hope you understand finding the equations of lines from graphs and slope-intercept and point-slope form and all that stuff. I hope it makes sense now. Good luck.